All right, we're moving on with the osmotic pressure lab, PhysioEx lab. And I apologize. I'm of the older generation and I just didn't maximize the screen last time. I'm not going to re-record it, but at least this time I blew up the screen a little bit so you can see better. Okay, so it says increase the glucose concentration to be dispensed to the right beaker to 8 millimolar by selecting the button beside the glucose in the right beaker. Okay, so I'm going to scroll down just a little bit and the right beaker. Okay, well, maybe I need to flush first, huh? Sorry. Okay, so now in the right beaker, glucose to 8. All right. But it seemed like it was also supposed to be 8 in the left beaker. If I'm wrong, I'm wrong. We'll just see. Oh, no. I see what I got it at 9 in the right beaker, so I need to start that. I need to start this over. Flush, flush. Maybe my mistakes will help you guys to not make the same ones. But from what I remember, you've got to make it 8 millimoles of glucose on both sides. So the concentration of solute is equal on both sides. Okay, so what we expected to happen happened. I mean, they were already equal, so you're not going to have any net movement of water from one side to the other. All right, now let me follow the directions. I know I need to record data. Then next, drag the 100 molecular weight membrane. Remember, we had 20 molecular weight, which has small pores, and then we had the 50 molecular weight membrane, which has medium-sized pores. And now we are using the 100 molecular weight membrane, which has even larger pores, and glucose is not being able to pass across. So glucose must be larger than the sodium and the chloride ions because glucose can't pass across the larger pores in the 100 molecular weight membrane. Okay, and then flush. And then next, why do you think there was no pressure change? There is no net movement of water because the solute concentrations are the same. Okay, and I haven't been hitting check answer. And you should do that. I'm sorry. But anyway, and if you don't, I think if you don't hit check answer and submit, then you can hit check answer, I believe, and then it will give you the right answer so that you don't have to miss the questions. It's what I'm understanding from it. So select deionized water and then dispense to fill the right beaker, right? I missed something. Drag the 200 molecular weight membrane and then increase the glucose concentration on the left to 8 millimolar. Dispense. Now I already did the deionized water on the right. Okay, so then I hit start. And now, notice what's happening with the glucose. The glucose is moving through that membrane because the membrane, and it reached equilibrium in 37 minutes, but that membrane has 200 molecular weight pores. So glucose must be larger than 100, but smaller than 200, because now instead of the water moving, the glucose is moving until both solutions have reached equilibrium. So I'm going to hit record data and then flush both sides. Increase the albumin concentration to the left beaker to 9 millimolars. Now, albumin is a very large protein that we have in our, it said 9, right? Okay, we have albumin in our blood plasma. It's also the same protein found in egg whites. Increase the glucose on the right beaker to 10 and dispense. What do you think will be the pressure result of the current experimental conditions? Well, I know the albumin over here is larger, so this solution is going to be thicker. It's going to be more concentrated. And the glucose is smaller. So, and I know the glucose will pass through the membrane, the 200 membrane, but the albumin I'm not sure about because we haven't done albumin yet. So, what do I think? I think the albumin is larger, so the pressure above the left beaker is going to actually increase. And click Start. And that's what's happening. Our pressure over our left beaker is increasing because water and glucose are moving from the right to the left, since both of those molecules can fit through the 200 molecular weight pores in this membrane. We should record this, record data, and then flush. And we are almost done. So 39 says, congratulations, you have completed the experiment. Submit your results to the lab report and proceed to the post-lab quiz. All right, and then post-lab, and notice that when we were back on the assignment in Mastering A&P, we clicked on the pre-lab quiz and it has taken us through everything. So it's taking us to the post-lab quiz, and it should also take us to the essay questions. So number 1, if you double the concentration of a non-diffusible solute, non-diffusible means it can't pass through the plasma membrane, what will happen to the osmotic pressure? It's going to double. If you double the concentration, it's going to double the pressure. And we can go back to our experimental results and view them if we need to. Which membrane did not allow sodium and chloride ions to pass through? And that was the smaller membrane, the one with the smaller 20 molecular weight pores. But you can always go back and look at your results. Okay, so let's view our results just so you can see that. You see, if you look at these results, when we had salt as the solute, and the molecular weight of the pores was 20, then the water moved to the left side. So the left side pressure was higher because water moved into that left beaker, whereas on the right side, the pressure remained low because no water or salt moved into that beaker. And you can keep on looking down and see all that in these results. and just see all the different results you got for your different experiments. When a solute is able to diffuse through a membrane, volume changes occur, equilibrium is reached, there is net movement of water, pressure changes occur. When the solute can diffuse through the membrane, we watched equilibrium being reached. So, because remember the glucose, if we go back to our experimental results, remember the glucose when we did, let's see, we did 8 in the left and 8 in the right. We noticed that the equilibrium was reached. I'm sorry, we started with 8 in the left. And, okay, where's the one where we start? It's not showing you the ending concentration, but remember we started with 8 in the left on one of them, and then it ended up with 4 millimoles of glucose on the left and 4 on the right, and no pressure change. I think that was this one here. And that's because the glucose could move until equilibrium was reached, until the concentration was the same. All right, water diffuses toward solutes. Always remember that. It diffuses toward the higher concentration. Now we hit submit, and now we have some essay questions. Explain the effect, and I'm just going to answer this one and stop here, but explain the effect that increasing the sodium and chloride concentration had on osmotic pressure and why it has this effect. How well did the results compare with your prediction? Our prediction was that the osmotic pressure would increase. So we have to answer this question to get all the points. So the first part says, explain the effect that increasing the sodium chloride concentration had on osmotic pressure. Increasing the sodium and chloride ion concentration also increased the osmotic pressure. That answers the first part, and then it said, how well did the results compare with your prediction? The results matched my prediction. As long as you answer both parts of the question, you're going to get all the points for that question. So I wanted to show you how to answer an essay question, but I'm going to stop here. And if you have any questions about this activity, just send me on the open forum for week 3. Just send me a message.